Team, it's Mr. Z, and we're going to continue decomposing functions. Basically, we're going to analyze two graphs, and we're going to talk about the product. Let's go ahead and do this, folks. So the idea is we are going to be taking two lines, and we're going to be multiplying them. Well, a degree 1, we're going to go ahead and let f of x go ahead and be. Now, I could kind of guess some things about this equation. I know that it's going to be increasing, therefore the slope is going to be positive. Likewise, with s of x, I also know the slope will be positive because it is increasing. So we're going to go ahead and sketch the product. In order to do so, I'm going to go ahead and look at the x-intercept of both lines. The 0 of v of x is negative 2. So for v of x, the x-intercept, the 0 is negative 2 comma 0. For s of x, my x-intercept is going to be at 0, 0. So this is going to define the behavior. In order to figure out the product, I'm going to look at the behavior of v of x and s of x. So on a number line, let's go ahead and look. My 2 points are negative 2 and 0. Okay, let's look at the region between negative 2 and negative infinity. All of these numbers, I'm looking at this entire space. And the idea of what I'm trying to look at right now is notice both the green function, v of x is negative. Notice s of x is a negative number. A negative times a negative is going to be a positive. Again, let me look at the next region. I'm going to go ahead and look at the region between 2 and 0. So I'm going to be looking at the space between these zeros. Notice two differences. V of x is above the x-axis, so it's going to be a positive number. Notice s of x is below the x-axis, so it's going to be a negative number. A positive times a negative is a negative. Okay, continuing my x-axis, I'm going to look in this last region, 0 onwards, and it's going to draw my attention to notice v of x has positive outputs because the line is above the x-axis. Notice s of x has positive outputs because it's above the x-axis. The product of two positives is a positive. So when I sketch through this, what I'm going to do is follow the behavior. In the yellow region, it is going to be negative up to the 0. So with my, or a positive up to the 0. So I'm going to go ahead and use purple to represent the positive. So it's going to look something like so. Notice the product is above the x-axis. Now between 2 and 0, it's negative. But after 0, it's going to be positive again. So it's going to be negative, but it's going to go to this other 0. Voila, I have my sketch of my graph. The x-intercepts, I don't even have to work too hard. The x-intercepts of p of x are the x-intercepts of x of x. They are negative 2, 0, 0, 0. Notice two solutions. This is a degree 2, which means it has two answers. Negative 2 has a multiplicity of 1. 0 has a multiplicity of 1. 1 plus 1 makes 2. Notice how everything aligns. Now, to find this vertex, we're going to do something actually very clever to find it. Normally, in the past, I can only find vertex if it's in vertex form. The last unit had you basically recognize that anything that looked like a times x minus a number squared plus another number, that the vertex was at this point, h comma k. And you also were supposed to know that the axis of symmetry was x equals h. I like to remember the x value of the vertex. But what did that really mean? Here, in this problem, it has the zeros of the x-axis. That's what makes them 0. This is at negative 2, 0. And this is 0, 0. So to find the vertex, I know that the axis of symmetry, what it does is it takes something at the vertex and it cuts it in half exactly. So in order to find this vertex, I'm going to actually go to the graph to illustrate this a little better. Here, this root, I'm going to go over 1. At this one, from the right point, the right root, I'm going to go to the left one, finding my axis of symmetry, the halfway point between my roots. This halfway point is going to be the vertex. My vertex is at x equals negative 1. The vertex is at negative 1, negative 1.